Okay, so absolute value of negative 40. What's it going to be?
40.
Positive 40. All right, so absolute value, you can think of it a few different ways. One way to think of it is how far away you are from 0. Okay, a distance is always positive, right? So it's positive. What about absolute value of 230? Oh, which one? Who's right?
It always has to be positive.
It is 230. I had a teacher, I thought this was a really good analogy right here, that called the absolute value bars the washing machine. If you put dirty clothes into the washing machine and wash them, what happens? They come out clean. If you put clean clothes into the washing machine and wash them, they still come out clean, right? They don't get dirty whenever you put them in there, so you wouldn't get negative 230. So whatever when you take the absolute value of something, you are getting a positive number for that. So let's look at the equations below. Example 3, 4, and 5 are some of the most simple absolute value equations you could possibly have. Okay, so what we're trying to find on absolute value of x right here, what number could I put in that would give me the right answer? Okay, so Gage is telling me 3. I agree. And then Gage is on top of it today. He's already given me another answer. Because what other number can we plug in?
5.
You're on the next problem. I could do a negative 3 right here. You've got 2 answers, right? If you put 3 in, you get positive 3 out. If you put negative 3 in, you get positive 3 out because the absolute value washes away the negative, right? Okay? All right, now 4. What number could I plug in that's going to give me negative 5? If I plug in negative 5, what will I get? Positive 5. Won't work. If I plug in 5, what will I get? Still positive. Okay? No solution for this one. He is. He's locked in. Okay. All right. So, what about the last one? All real numbers means every number there is. That means I could plug in 1,000 and it would work. Is that going to work? No. No. So, no solution means nothing works. All real numbers means everything works. Neither one of those are the answer for this. It is just 0. Okay. Now, normally, I got a positive and a negative number that will work. But am I going to have 2 answers for this one? No, because there's not a positive 0 and a negative 0, right? 0 doesn't have a sign. So, when we're solving absolute value equations, you have 3 types of solutions you can get. You can get one solution. That's going to happen whenever your absolute value bars are equal to 0. Okay? You can get 2 solutions. That is going to happen when your absolute value bars are equal to any positive number besides 0. Right? I guess not. You don't even have to say besides 0 because 0 is not positive. Okay? And then the last one is you can get no solution. And that is going to happen whenever you have your absolute value bars equal to a negative number because we can't have that happen. Okay? Obviously, it's going to get a little harder than these, right? Because that is pretty simple. So we can't be that lucky. So what I've done here for our notes is I've got just the regular equation, and then I've got an absolute value equation that's basically the same, right? Because we need to make sure, because I know that Math 1 was a really long time ago. And I bet if I gave you guys the Math 1 EOC right now, our results would possibly be embarrassing, right? So I know you have forgotten some things. I know this because back, it's been like 10 years now. Whenever I started teaching calculus, I was good at calculus. I made a 5 on my AP calculus exam in high school. I was really good at it. And then when I started teaching calculus, I realized I couldn't remember how to do any calculus, like almost nothing. And I had to sit at the kitchen table every single night doing the calculus homework that the kids were going to do the next night, teaching myself how to do it. It was really hard. But now I know how to do it pretty well, but it was really hard for me to read. I relearned it more quickly than if I'd never had it, but it took a lot of work. So I know that since first semester freshman year, you guys have probably forgotten a few things. So we want to go back over it. So let's look at this equation. Let's see. Ricardo, what would I do first on this one? Okay, when we were solving an equation, we're trying to get that variable right there by itself, which means we got to get rid of the 2 and we got to get rid of the 7. You want to get rid of whatever's furthest away from the x first. So we don't want to mess with this 2. We want to do the 7. So how do I get rid of that minus 7? I'm going to add 7. And that'll cancel this out. So I'm going to add 7 here. Okay. So that leaves me 2x. I'm going to bring that down. And then I've got 18. All right. Then, Ricardo, how do I get rid of that 2 right there? Good. And what will I get for my answer? 9. Okay. So that's how we do the first problem, no absolute value, right? Let's do the same problem, but let's put some absolute value bars around 2x minus 7, okay? Now, for this, I got 2 numbers that I can get right here for this stuff that will make it work, right? I can get 11 inside of these bars, right? What else could I have? Nope. Like 2x minus 7. Whatever this is, it could. I need what's inside to equal 11. There's another number it could equal, and I'll still get 11. So, negative 11, right? Because if 2x minus 7 equals 11, positive 11, then I'm going to have a positive 11 on the inside, and positive 11 equals, absolute value positive 11 equals positive 11. But I also could do 2x minus 7 equals negative 11. Because if I get a negative 11 right here inside of these bars, the bars are going to wash the negative away, and I'll have a positive, right? So when you're doing an absolute value equation, you want the absolute value bars by themselves first. They are on this problem. And then you just have to write the problem once, like it looked in the beginning. And then again, with a negative answer. Notice I did not change anything over here. 2x minus 7 stayed exactly the same. But I changed my 11 to a negative 11. Now, we already solved this problem up here, right? 2x minus 7 equals 11. I just got x equals 9. I'm just going to write it down since we already did it, right? That's one of our answers. Okay. Then we're going to solve this other one here. So for this, Madison, what would we do first to solve 2x minus 7 equals negative 11? Okay, we're going to add that 7 again. It's basically the same steps, right? Except for we're just going to get different numbers because this time we're doing negative 11 plus 7. What do we get for that? Brian? Negative 4. So we got 2x equals negative 4. Okay, and then let's see, Madison, what would we do after that? Good. We'll divide that by 2. And so we will get x equals negative 2. So you're getting 2 answers here. You got x equals negative 2 and x equals 9. I didn't solve it, but it's just like you're solving 2x minus 7 equals 11. I just didn't do it because we already really did that in example 6. When you write the equation, you're going to write it twice, and it's always going to be, one time it's going to be exactly the same as it was, just the bars are dropped. Second time, you want to make this answer right here negative.
Why'd you make it negative?
Because, like, if I think about plugging my answers back in to see if they work, like if I do the absolute value of 2 times 9 minus 7, right? That is going to give me 18 minus 7 inside those absolute value bars. That'll give me absolute value of 11. That gives me 11. That works, right? But I could also do this. 2 times negative 2 minus 7, right? Try my other answer. That's negative 4 minus 7, and that is negative 11. And if I get negative 11, the absolute value bars wash it away, and it also gives me positive 11 for that. So that's the reason we need to do the positive and the negative for that. If you only solve it like the negative's not there, you only get one answer. That one answer will probably be right, but you will be missing one of the answers, so you wouldn't like get full credit for that. Okay. All right. Let's see. All right. I think I'm going to go ahead and show you this. I'm ashamed to do this, but I know we need to check ourselves. I also know some of you are pretty weak on solving equations. Pull up Desmos, everybody. You should already have Desmos up there. Pull up your test in Desmos there. I'm ashamed to even do this. You should know how to solve an equation without having to rely on this, but Miss Martin and I have had some pretty good Math 3 scores relying on this the last couple years. Okay. Let's check our work with Desmos. Okay. If you were in the North Carolina version of the graphing calculator, then if your absolute value bars, you have to click right here, and they're right here. So absolute value of 2x minus 7 equals 11. It won't do it for you. It'll give you an error. If you're in the real version of Desmos, it will give you some vertical lines at your answers, but we have to use the testing version, right? So it won't do it for you, but here's what we're going to do to check, okay? What we're going to do, and this will work for any equation that you're doing, I'm going to let the left side right here, I'm going to call that f of x. Okay, so that means over here, I'm going to type in f of x equals absolute value bars 2x minus 7. Absolute value graphs look like a V. We're going to talk about those and what the graphs do later, but for right now, we just see that it pops up. Okay, then we are going to take the other side of the graph, the other side of the equal sign, the 11. We're going to call it g of x. G of x. It doesn't really matter what letters you use there. It doesn't have to be an F and G. I just usually use that because it's pretty standard. It is going to graph us a horizontal line. Okay, here's all you got to do. You're going to look for where they cross. What do you see the x is in that coordinate? Negative 2. That was one of our answers. If I go over here, what's my other x? Positive 9. That's my other answer. So we can use that to check our work. Now, right now, I want you doing it by hand also. So you're going to do it by hand. You can use this to check your work. When it comes quiz time, if you're desperate, you can do this. We have to do inequalities. They're not going to be quite as easy on Desmos, so you need a background in this. Don't just use Desmos on everything. But, like, for example, here, I'm just going to show you quickly, and then we're going to look at how to solve it by hand. If I want to solve this one on Desmos, for example 8, if I use Desmos, it's always the same. See, this one isn't even an absolute value problem, but I could take the left side. I'm going to call it f of x, and I'm going to take the right side, and I'm going to call it g of x. So f of x equals x over 3 plus 2. G of x equals 8. It's going to graph 2 lines for me. I'm going to look for where they cross. What is my x coordinate? 18. 18 should be the answer for this. We're going to solve it and make sure it is. But 18 should be the answer. So that method works every time for these. Now, sometimes you have to zoom and it's a little tricky, but it should work every time. But let's solve it by hand. I want you to know how to do both ways. These problems send children into an immediate panic attack whenever they see that there's a fraction. You can admit it out loud if you want. Some of you have a panic attack every time you see a fraction in a problem, right? Yeah, several of you are saying amen to that one. But this one's really not a fraction. Like, you don't have to deal with fractions to do this. Fractions are just another way of doing division, right? It's also just division. So we're trying to get that x right there by itself. We got to start furthest away from the x. So Yair, what are we going to get rid of first? Yair, -2. Okay, we're going to subtract that 2. That's going to leave us x over 3 on this side, and we're going to get 6 over here. So don't think of this as like a fraction that's complicated. This is x divided by 3. Alex, what's the opposite of dividing? Multiplying. So what you're going to do is you're going to multiply this side by 3 in the top. When you got a 3 in the top and a 3 in the bottom, they cancel each other out, which is what we want to happen, right? And then if you multiply by 3 on one side, you have to multiply by 3 on the other. And so 6 times 3 is going to give us 18. That's the answer we got whenever we did it with Desmos. Yes. What did you do?
I multiplied the whole thing by 3, and then multiplied 8 by 3, and then I got 24, and then I got 8 plus 6.
That works. You just the thing kids do wrong a lot of times is they don't multiply the 2 by the 3. So I think I'm not going to show them that way because I'm afraid it'll further confuse. But that is fine as long as you're multiplying that 2 by the 3 as well there. So yeah, that'll work. There. I love different. I try not to show too many ways to solve a problem because sometimes that makes kids more confused. But I am perfectly okay with different ways to solve problems as long as they are mathematically correct. And like what Austin just explained is there. So, okay, example 9. Now, in this case, my absolute value bars are not by themselves yet, right? I got other stuff on the outside of the absolute value bars. So what I need to do is I almost need to try to like solve for this. I got to get this by itself first before I write 2 equations. You cannot write 2 equations until you have got that by itself. So I'm going to put a line right here, and I need to try to get that absolute value of x plus 5 by itself. That means I got a 2 and a 3 that I have to get rid of. So Gerardo, what do I do to get rid of that 2?
Oh, you subtract it.
Good. Good, so that gives me absolute value of x plus 5 over 3 equals 6. Okay, what would I do next, Gerardo?
You multiply 3 on both sides.
Multiply by 3. Notice this is like, it doesn't look like it's the same problem, but is it kind of the same problem that we were just doing? We subtracted 2, we divided, multiplied by 3. So we got absolute value of x plus 5 equals 18. Okay, so you got to get absolute value bars by themselves. When you get here, when the absolute value bars are by themselves, you got to have 2 answers. Okay, you got to have 2 problems. So the first one just looks like this. X plus 5 equals 18. The second one is going to be x plus 5 equals, who can tell me? Negative 18. Okay, everybody good there? Now we're almost done. Isley, how do I solve this first one? Very good. I'm going to subtract 5. So what will I get for that answer, Isley? 13. Beautiful. And then, Josue, what about the second one? What do I do here?
Subtract 5.
Beautiful. And what will I get for that answer? Negative 23. Okay, so I have 2 answers for that problem. Now, keep in mind, I'm going to pull it up and show you because while I do want you to be able to do this by hand, if you can't do anything, you could at least type it into Desmos. I could do the left side, absolute value of x plus 5 over 3 plus 2. Right side is 8. That is going to give me this graph right here. It's going to cross right here at 13 and over here at negative 23. Those are my two answers, right? So you can check yourself with this. Okay, questions? Okay, now on this slide, I have those steps written down for us. Okay, so the first thing we're going to do is to isolate the absolute value. What's that word isolate mean? Get by itself. If you're in isolation, they are putting you alone. There, so you get the absolute value bars by themselves. This is an important note right here. Never distribute into the absolute value bars. Okay, here's what that means. That means you cannot do this. You cannot multiply like that and get 20x minus 40. It doesn't work. It'll work with parentheses, but not with absolute value bars. So don't do that. That is wrong. I'm going to erase it. Okay. Then once those are by themselves, you're going to split the equation into two, one with positive, one with negative. And then you can check your solution by substituting your answers into the original problem or typing it into Desmos if you would rather for that. Okay. So let's do this problem. Avea, what should I do first for this one? Beautiful. We're going to add that 3. So we got absolute value of 2x plus 6 equals 16. Jalen, have we isolated our absolute value bars? Are they by themselves? Nothing on the outside of it, right? We still got stuff on the inside, that's fine. But nothing on the outside of the absolute value, so they're by themselves. So what do we have to do now, Jalen? Okay, we're going to make two what is it, Yair? Make two equations. The first one, you just drop the bars. 2x plus 6 equals 16. What's the second one going to look like, Jalen? We'll have a negative 16. Okay? Noah, how do I solve that first one? What? Okay, good. So we got 2x equals 10. And last step on that one, Noah? Divide by 2. X equals 5. Okay? Lily, how do I solve the second one? Beautiful. So I got 2x almost 22. Yep. And then? Beautiful. Okay. And just to make sure you guys see me do this again, like every time, absolute value of 2x plus 6 minus 3. Type that in here. G of x equals 13. They cross at negative 11 and 5, which are the two answers that we got, right? So we feel pretty good that we got it right. Okay? Questions here? All right. Brian, what about example 11? What are we going to do first on that one? Good. Okay, so I will get 4 absolute value of 5x minus 10 equals, what are we going to get there, Brian, when we do negative 20? Very good. What should I do next? We don't want to do two equations yet because we still have something on the outside of those bars. What's on the outside? 4. We got to get rid of that 4. How do I get rid of it? Not multiply. It is multiplied by the bars. I want to divide it. Because if it's just sitting out front, it means that it's multiplied by that stuff. So I'm going to divide by 4. And I've got absolute value of 5x minus 10 equals -5.
Do you make the 10 solid?
You do not. So what's on your final answer? Like once you plug the number in, it's going to make it positive, but you can still have a minus on the inside. So you don't, that's a good question though, because I know Miss Martin said in her honors class, there was somebody that did the whole worksheet wrong because they were doing that. So you do not change that 10 to a positive there. It'll take care of itself as you solve. Okay? Tell me what you did. Before I add 10,
Well, you put the,
I got to make two equations, right? So I'll have 5x minus 10 equals -5, and 5x minus 10 equals +5. Okay? So then Austin is telling me to add 10, which is going to give me 5x equals 5, and then divide by 5, and I'm getting x equals 1. Okay, good. All right, let's see. Skylar, what am I going to do on the second one? Good. And so I will get 5x equals 15, and then? Very good. And that is going to give me x equals 3. So I got 1 and 3. Anybody type this in Desmos to check it yet? Let's do it. Everybody type this in Desmos and check it. I'm going to freeze my screen while I'm typing it in. I want you guys to do it on your own. I'm going to come around and see if you've typed it in. Right. So everybody type that in Desmos. Oh yeah, it's there. It's there. Yeah, typed it in perfect. We got a problem.
No, that's a little far.
Which is why I'm making it type it in. I need to see everybody's got it typed in. You're doing f of x. So what you're typing in there is you're doing or did you? I'm making you do this one because this one's weird.
I typed it in, right? The vertical line's not right. I mean, that part wrong. Yeah, that's exactly what I got on my screen.
This is your f of x. Your g of x is 3. A lot of you have it pulled up, but you're like, ooh, something wrong, didn't it? Desmos is telling us otherwise. Desmos is saying, oh. Desmos can be wrong if you're using it wrong, but it's usually right. Like if I did the problem by hand and did the problem with Desmos, if I knew confidently how to do it with Desmos, I'd go with my Desmos answer. Because it's not gonna, Desmos, you can tell Desmos to do something incorrectly, so you'll get a wrong answer. But if you tell Desmos to do it correctly, it's gonna do it correctly because it's just a program. It's not a. So I have also typed this in. I am also getting a graph where I've got this V way up high and a horizontal line down here. Where do those two cross? Nowhere. That's telling me no solution. That's what that's telling me. Okay? So let's go back and look at our work. Did I just let y'all do something totally wrong?
I think I did, right?
Yeah, you probably typed something wrong. You didn't put the plus 23. Yeah. Yeah, so something's not working. Does anybody know why this one didn't work out?
We did it wrong. You know what?
I know why, but I want y'all to think about why.
Are you gonna tell us what we're doing?
No.
Wait, so you knew it was wrong?
Because this is how you're going to do it. Like, if you're working through, this is what you're going to do. And then I'm trying to prove to you, number one, that you should check every problem on Desmos. Because this felt good, right? Like, we felt like we had it on that.
Did we miss a step?
You missed, like, a red flag.
It's because the -10 is took after the 5.
It's not the -10 that's the problem. But there is a negative that's a problem. What do you think, Madison?
X equals 1.
Negative.
The fourth. Negative 20.
Let's
Oh, I
look.
know what the problem is. So for the 5x, the absolute value, we put the negative to the positive.
Oh, look right here. Okay? Now, we didn't mess up necessarily. We missed this red flag right here. Whenever you get right here, now you have to solve it for the absolute value bars first. So, like, in the beginning, it didn't even equal a negative value, right? But right here, we've got absolute value equals -5. Can it happen?
It can't equal negative.
Yeah, absolute value cannot equal equal with the line through it means cannot equal a negative number. You guys knew that on the ones where we had like absolute value of x equals -5. I gave that to you before, right? And you guys figured that out. But when you're doing a problem like this, you got so many steps you don't recognize it. So what we should have done is when we saw this -5 right here, we should have said no solution. Okay? Because all of this work is invalid because absolute value cannot equal a negative. If you notice that you're writing your two equations and the first one is negative and you're changing the second one to a positive, that's not right. You shouldn't be doing that, right? So you should have no solution. But I'll tell you, like when you're doing, you're not going to get many questions that are no solution. There'll be a few. But when you're doing these problems, it's going to this is going to feel right. You're just going to keep on going. That's why I want you to check every problem on Desmos. Because on Desmos, we saw, oh, wait, this is not right. I'm not getting the right thing. And that'll make you go back and think on those. Not to mention that you could have just added something wrong, and Desmos will catch that as well. So I want you to check. I want you trying by hand, checking every problem with Desmos. Okay? Does that make sense? Okay, and then there is one more type of problem that the state of North Carolina says that we have to solve. And if you were in Honors Math 3, I would most definitely make you learn how to solve this problem. If you're like, hey, I'm an advanced student, I want to learn it, I will gladly show it to you sometime outside of class. But we are in regular Math 3, and we do not have the time. I truly believe you guys could learn how to do this. It would just take us a while because they're pretty hard problems. And we got a limited amount of time. So if we see a problem like this, what's different about example 12? Yeah, we got like an X over here on the side. It's not just a number this time, right? So if you see one where you've got X's on both sides, we are going to say that the left side equals f of x and that the right side equals g of x, and we are going to type it into Desmos. So let's do that. I want you guys to do both of these in Desmos right now. I'll show you the first one to make sure you're with me. The first one, the left side is, you're going to say f of x equals, some of you are lazy and you're not typing f of x in. You can get away with it on some things, but not others. Just put it in. It doesn't take that long. Absolute value of x plus 5 And then g of x equals 3x minus 7. Thank you, Matthew.
Yeah, you gotta put the absolute value.
Yeah, make sure you put the absolute value around that x plus 5.
Oh,
Okay? All right. Which of these 6 or 11, which one is our answer? 6, because we're finding an x, right? We want the x coordinate. So our answer for that one is x equals 6. Okay, does that make sense? Try the next one on your own. I'm going to freeze my screen so you can't see it. And I'm going to come around and see if you've got it. Everybody needs to type it in on their own.
Go.
Okay, then it's time to come hit the house, but back to like regular. Seeing graphs. It's looking pretty good. All right, what are we getting for our answer? 1. I don't know about that -1. You did it by hand, and no, I don't know what you did, because you should get a +1. All right, you just graph it like this. You should get x equals +1. We're looking for here. We should say intersection in this blank. Intersection means where they cross. We still got 5 minutes, guys. Hold on just a second. Make sure we get everything filled in good. We are looking for the x coordinate.